In this video, I'm going to show you how to create what I call dummy crowds, which is a very simple and efficient way of populating your environments with characters. I've used this technique in many movies and TV shows in the past. I remember especially using this technique a lot in the Assassin's Creed movie, where hundreds of soldiers ran across cities and battlefields. This is a short video covering the basics of this technique, but I will be covering this and more in my upcoming video about Houdini Solaris and Katana interoperability, which will be available soon on my Patreon. I will leave all the links in the description so you can stay updated. So this is the type of effect that we are trying to achieve here. So this is, again, what I call dummy crowds. And that means that we're basically creating a bunch of characters, could be hundreds, thousands, even millions of characters that behave like they are performing some kind of action, like walking around or running around or jumping or whatever, but they are not smart in the sense that this is not a crowd system. There is no logic behind this. These characters are not smart. They wouldn't be able to interact with objects or to run away from something because something is chasing them. They don't know where the other characters are in space, so there are collisions sometimes in between them, unless you fix those manually. And they are basically not smart. But there are many shots in movies where you actually don't need a smart crowd system, because they are so far away that you don't really see what they are doing. Imagine that you have a battlefield and you have a very wide shot, and the only thing you see is hundreds of thousands of soldiers just running around because, there is some action happening and they just want to exit the place, or they just want to go from point A to point B. There is no need to create something that is intelligent, right? You just need chaos happening in the screen. And that's where this way of working comes very handy. And again, I've used this in many, many shots in my life. And the good thing about this type of technique is like you are basically self-efficient. You don't need animators to do anything for you. You don't need a simulation or crowd department to provide you with the agents or the soldiers or the characters or whatever. You can do everything by yourself if you are a lighter or a scene assembler and you just need a bunch of characters in your shot. So again, this doesn't replace a real crowd system, but you can survive with this in many, many, many cases. So let me go through everything with you. The first thing that you need is a source animation, right? I have a bunch of animations here, so let me just go to import FBX, and I have actually only a couple of animations here, so I'm going to import running and walking. I have only 2 motion clips. So this would, generally speaking, your source animation. In my case, I'm just downloading these mockup samples from Mixamo. But if you're working in a visual effects studio, of course, you wouldn't be able to use resources from the internet. You would be using internal libraries of motion capture, which is what I've done in the past. But imagine that this is just a mockup clip that you have in your studio. In my case, let me set this to start frame 0. And when you're working with mockup, generally speaking, the first frame or potentially negative frames, they are going to be the T-pose, which in my case is frame 0. And then in frame 1, we get the animation. So this animation goes from frame 1 to frame 50, I believe. 49, 50, 51. Yeah, 51 is not animated anymore. So 50 is the last frame. So the first thing that we want to do here is to extend this animation. We don't always have to extend the animation. It depends, of course, on the length of your shot. If we're doing a shot that is only like 25 frames, this animation is 50 frames, so we're good. But let's imagine that we're doing something that is, 100 frames or 90 frames or 60 frames. We only have 50 in this character animation, so we need to extend that. That's the first thing we have to do. The second thing that we have to do, we need to retarget this animation into our character. This is a generic mockup rig, which is fine. Mockup rigs, they tend to be very similar. They change depending on the system that you use, but generally speaking, they are all the same in the sense that they are biped, right? They would have 2 legs, 2 arms, chest, spine, head, neck, and so on. So it's very easy to retarget animations from one biped character to another biped character. We're not going to cover that because I made already a video for my YouTube channel. I'm going to leave a link in the description so you can take a look and see how I do it there. I recorded that video a while ago, so I don't remember exactly what I did, but I believe that I use both Maya and Houdini. So you can use any of those software to do it. Any 3D animation software has some kind of retargeting tools, but Maya and Houdini are the ones that I use, so you can just take a look at that video. Another thing that we need to do here, first of all, is go to create one of these test geometry template body. And we can see that the mockup came very, very large. So let's transform these into the Houdini's unit system, which is meters. So yeah, when I go inside of this FBX animation, basically I get a rig here, and the root is the hips. So I just need to create a null. Oops. Connect the null here and scale everything by 0.01. There you go. And now we're working in Houdini's units. So let's get rid of this guy and carry on. Again, frame 0 is T-pose. We don't really need T-pose. We're not going to delete that information because it might come in hand later, but for now we don't need it. So just go here and set your timeline to start at frame 1. And we said that this animation is, what was it, 50 frames? So let's extend this to, let's say, I don't know, 90 frames or 99 frames. Let's pretend we're doing a shot with where we need, I don't know, 60 or 65 frames or 70 frames. So we only need 90 frames of animation and then we're safe. If you have a longer shot, just extend your animation by 200 frames or whatever. Okay, so let's see how we do that. So if we take a look at the viewport, we can see that this character is moving forward, and that is the set positive axis. So we need to select the hips, which is the root of the character. Let's open the animation editor. And because it's moving in set, that's the only axis that we care about. So let's select translate set. And here we can see our animation. We can see that this is a very linear animation because it's basically moving forward. So we don't need, I mean, all these keys that we have here, they are basically noise. So we don't need that. Let's get rid of that. And then frame, as you can see here, we still have frame 0, which is the T-pose. And then in frame 1, we start our animation. So let's extend these in a linear way. And what I mean by that is, so from 0 to 50, let's move the same distance at the same speed, double time. So frame 90, we're going to move from here to up there. So the first frame, we have a value of 88. So we can eyeball this, or we can just use some simple maths. So let's say 88, and the last frame is 416. So let's do 416 minus 88. Was it 88? 88, yeah. So that gives us 328 units that this character has moved forward. So let's go now to the last frame, which is 416. So let's plus 328, which is this movement. So we move the same amount that way. So if we take 328 plus 416, we get 744. Same frame, we said 99. We want to do 744. Give it a keyframe. Commit change. And now we can see that the character starts there, starts walking, and then it continues sliding. Of course, the rest of the bones are doing nothing because the only thing that we animated was the translation. And also, let's keep this linear. So set that one to linear. There you go. Okay, cool. That's great. Next, let's take care of the rest of the body. So let's go here and select everything. The only thing we don't need is this null that we created before, and this stuff at the very far right here, which is basically the materials. So we don't need that. And the geometry, we only need these bones. So now I don't need a calculator anymore. Let's open the animation editor again. And here you can see the translation in set that we animated already. We don't need that one, so let's just deselect it here. There you go. And now let's select all these keyframes except the very first one, which is the T-pose. So frame 0 we don't care about, but frame 1 to 50 we do care about. Now we go to the next frame where we don't have animation, which is frame 51. Now we can just copy those keyframes and paste. There you go. So now we have extended the animation. So if we take a look here, now we can see that this animation is actually 99 frames instead of the original 50. If you have a longer shot, just repeat the same process. And that's it. We don't need any animators, or we don't need anyone to do this for us. We just do it ourselves. As simple as that. All right. Then, to use this in a crowd system, we need to bake it or cache it. Or actually, because we're going to be using Solaris, we don't need to cache it. We can basically just import this in lobs. That will work. But I always prefer to work with caches. So we can cache this as an Alembic file. So we can just go to the out context, create an Alembic node. Oops. And here, basically, we would export the Alembic using the frame range. And then here, we just need to select that guy, and it will export only this character. Save to disk, and it will export it. You can do that. You can also select this guy and go to File, Export, Alembic, export it somewhere in your hard drive. Use the frame range and select the character here, and it will be exported. That's it. If you're working in SOPs, if you're doing this in SOPs instead of LOBs, you actually need a BGeo or FBX or whatever, but not a packed Alembic. So let me go here to mockup. And what I have here is basically the same thing, right? I just have this animation that I exported as an Alembic. So this is the Alembic, which is great because it's not exporting the bones or anything. It's just the baked geometry. And then this one, I created a raw geometry output, and I exported this as a BGeo sequence, which is this guy here. And this is something that you would need for SOPs or MOBs. Because this technique that I'm going to show you, you can do it in a different way. But now, thanks to LOBs, thanks to USD, thanks to Solaris, it's way easier and faster than before. Before, you had to do it in SOPs, and it required a little bit of adding wranglers and coding with PEGs. It wasn't very complicated, but you had to do it yourself. Now you have the tools to do everything automatically for you. So it's much, much better. So I'm going to show you that technique. If you're interested in the SOPs way of doing it or in the MOPs way of doing it, because there are a couple of ways of doing it, let me know and I can maybe make some videos about that. But let's go for the easiest way, which is doing it in LOPs. For LOPs, you can use either BGeo or Alembic. It doesn't really matter. And I've done exactly the same, but with this running animation. So I exported that one as well. And we have a running guy for another 99 frames or something. There you go. Just like that. And these are the mockup clips that we're going to be using. If you need more, just repeat the process with other animations. You can have different mockup animations of people walking and running. So you can have maybe like 5 different people that have been motion captured who are walking, and another 5 who are running, another 5 who are doing another type of action. It doesn't matter. So the more, the better, I guess, in terms of creating complexity. But again, for a wide shot like this, with a couple of mockup clips for walking, another couple of mockup clips for running, it will be probably enough. So now that we have all of these, let's just jump into Solaris. And we can create our crowd dummy system here. So let's go to stage and we can continue from here. Okay, so the first thing here, let's bring those mockup clips. So if those are published, you can basically just bring them as references. We don't have them published, so we can just sub import them. So let's just create a sub import and bring the running let's say walking BGeo cache. There you go. Let's rename this one to something like walking. And now we should have this guy walking. Okay, so let's set the length of our shot. So we gave these characters like a 99 frames of animation because we said that we're going to have something around, I don't know, whatever, 65 frames for our shot. So we have plenty of animation. Again, if this shot was longer, then we just need to extend our animation longer. But this should do for us. Okay, let's also bring the running mockup. Okay, and now we have a running guy and a walking guy. Again, this is only a couple of clips, so of course it's not going to look amazing, but well, I mean, it's going to look just like this. This is what I'm using here. But if you want to use more mockup animations, just add more clips. All right, so the next thing is we need to create our crowd systems, and it's going to be as simple as creating instances, right? So let's create an instancer. Let's go inside. Let's create a geometry support. So that would be the geometry where we want these characters to be populated. So let's just create something like 25 by 25. Okay. Let's add now and scatter and align node. And in this one, this would be the amount of characters that we want. So I'm going to set the point cloud method to number of points, and I'm going to set this one to, let's say, something like 40. So we would have 40 characters, which I believe is what I have here. It's only 40, but if you want to have 1,000, then you use 1,000 points. Okay, cool. So next, if I just connect the walking mockup here, that's what we have. We have all these guys. And if I actually ignore this guy, as you can see now, we have like an army. So if you have like a wide shot like this, where you have, I don't know, a battalion of soldiers marching, now you press play and all of them will be moving forward. So for some kind of army that is just marching, this will work, right? I mean, you add a couple of offsets and that's it, done. But let's not stay that simple. Let's do something a little bit more complex. So yeah, let me enable this guy again. So now we get these guys. And as you can see, the size is changing. And that is because by default, the scatter on a line exports the p-scale. So for example, in the coverage, if we set this one to less, you can see we get less guys or more guys, but the scale is changing. We don't want that. So let's go to attributes and remove the p-scale. So now they have the original scale. Okay, and of course, you know, even though we're only using a couple of clips of animation, this could be looking much better if we had different characters, even if they use the same mockup clip, right? But if these characters were all like different hairstyle, different costumes, different everything, it would look better even though they are using the same animation. It would look more randomized. Okay. So now we have these guys and they are basically being animated, but they all move exactly the same way and all of that. Again, in SOPs, if you want to change the offset of the animations or the timing of the animations, you need to do it with Wranglers. Here, there is a node that does everything for you, which is great. Maybe you don't have that much control, but for a dummy crowd system, it's good enough. Okay, so yeah, let's do that. Let's play with the offset so we have these guys moving in a different way. By the way, all of these guys are just moving forward. Maybe that's something that you want. Again, if you have an army that is running from point A to point B, probably they will be running all in the same direction. But if you want to add a little bit of offset, you just go here and in this rotation around normal, you add a little bit of offset there, and then you know they have different directions. Or if you want to go completely crazy, set that one to 360, and now they all go in different directions. So if this is a square in a city, you would do something like this. If this is a battle, then you probably want them to point towards the same direction. Great. What else do we have to do here? Well, nothing really. We just need to retime it. If these characters were published as USD files, then the only thing you need to do is add a retime instances. And this will retime it based on these settings that we're going to take a look in a minute. But because this is not published, this is just being imported from SOPs, you need to cache them. And by cache them, I mean publish them or just add a cache node. So they will be computed every frame. Again, if they are published as USD files, you don't need this cache. So now we just connect this one here, and then this will work. So in these retime instances, we can say something like a frame offset. So let's say that I give this offset of 10 frames, and then we can give it a time scale. So if I set this one to 2, it will be slower by 2 times. Or if I set this one to 0.5, they will be faster by half. So I'm going to give it like a very slow value, like 4, so we can actually see it. We need to specify the instances here, so we can just select which instances we want to be slower. So I'm going to select this character, just that one. And as you can see here, it's basically looking into the instancer1 node, which is this one, at the point instance 22. So look at this guy, and you'll see that it's going way slower. You see, it's super slow. So that's basically how you can tweak these animations. If instead of selecting one instance, I select a range, for example, from instance 10 to instance 20. So 10 different characters. As you can see, they are selected there. If I play this, now we have a bunch of characters that are moving very slow. Okay, so what I usually do with these, and again, this is maybe not extremely procedural or 100% procedural, but almost there, is just concatenating multiple real-time instances affecting different characters. There is a problem though, and it's like it doesn't work. So basically, if I say I want this one to affect instance from 0 to 20, and then another one that is affecting from, for example, 20 to 40, this doesn't work because concatenating these guys doesn't work. It's a limitation of these nodes in stage. So the workaround is this. Instead of selecting the instances here, I'm going to select the instances here. So in this real-time instance node, I'm going to affect all instances by just doing that star. So now all of them are super slow. But I can select which instances I want to affect here. We can do it in multiple ways. I mean, this is just regular subs. So for example, you can just create a group node, set this one to points, and then just select a bunch of them. So I'm going to select these guys. I'm going to blast the opposite. So I'm going to select the group and delete non-selected. So I keep only those that I selected there. And now this will be affecting those. Okay. And then I will duplicate these, select other instances, and then merge them all together. So you can use this method. You can also use group by range. So you can just connect that one there and say, I want to select a range of, this one is run over points, a range of this, for example, from 1 to 6. Then you would blast them also. And now this is a little bit more procedural because you can change this range all the time. And that would work as well. So either way will work. Of course, in this group, you can also do a range. So let's say from 0 to 10. So that would be 10 characters. So I want to keep only 10 characters. I'm going to give them a value of, let's say, this is super slow. So let's do 1.5 and an offset of 5. There you go. And by the way, let me merge these two characters here. So that one goes here, that one goes there, that one goes here. Okay. So now that's what I get. Okay, looking good. Also, let me just add here. I can just add a randomize attribute to give them like a random color. Okay, now I'm going to duplicate this guy. And here I'm going to change the range. So instead of 0 to 10, I'm going to select from 11 to 21. And so now I have different characters, and these ones are going to have a different offset. So maybe if offset 10, and these ones are going to go faster, so 0.8. So they go a little bit faster than these other guys. Oh, by the way, let me change this one to instancer 2, otherwise it's not working. There you go. Yeah, now it should work. There you go. So these are just faster, right? Maybe this is just too big. So let me set that one to 2. Okay, great. So if we merge these two guys, now some of them are faster, some of them are slower. Okay, let me duplicate this one and carry on with the rest of the selection. So in total, I had 40 characters, right? We set this one to 40 characters. So let's select now from 22 to 32. And now here, I want this one to start at frame 0 and to move just as regular, something like that. This one needs to affect instancer 3. There you go. And finally, let's get the rest of the characters. So that will be from 33 to 40. And this one runs over instancer 4. And let's say I want these ones to be super fast, like 0.5 and start at frame 3. Connect all of them together. And now we have characters with different offsets, different timings, and whatnot. So all of these should be just working fine. There are some playback issues sometimes, but that's fine. That works just okay in the final render. As you can see here, this is pretty much the same stuff. You can see they render fine. Okay, that's pretty much everything you need. So again, this is not super smart, but they just work fine. And if you just need like tons of characters doing their thing, that's it. It works. Right, so from here, maybe you can just use a merge, create a grid. Add the grid in there. So now we have something there. Okay, let's add a camera. So we have, oops, let's look at the camera and let's create like a wider shot. So something like that. Let's move that all the way down. So from here, let me create a material library and create a couple of materials. Just gonna add a principal shader that I'm gonna call gray material. And now I'm gonna duplicate that one and let's call this one characters material. Set this to 0.4. And this one is using point colors. It's gonna give us like a random color for each character. Create an assigned material. And I'm gonna take the grid and assign the gray material. And I'm gonna take all my characters and assign the characters material, and they should get like a random color. Great. Next, I'm gonna add a DOM light, which I'm gonna set to lat long and use a random HDRI that I have somewhere. There you go. And finally, some Karma render settings. Okay, so if I look through my camera and I render this with Karma, we should get everything working. Let me zoom in by using the native viewport camera. And as you can see, the characters have motion blur and everything, right? So you can see let me go to a different frame perhaps. So you can see this character that is running that has a lot of motion blur. That is because we added these cache nodes here. Otherwise, they wouldn't have motion blur. Well, if they are published USD assets, they would. But if you're just sub-importing and you're not using a cache, then you wouldn't get any motion blur. So yeah, that's pretty much how you do it. So as you can see, again, this is the final render. Super simple, but it just does the job. I mean, this doesn't replace any crowd systems, but it just does the job. And again, you are self-sufficient, right? By yourself, you can generate the animations, you can just extend the range of the animation, and then you can use as many motion clips as you want in this very simple but efficient crowd system. I hope you find this technique useful and you like the video. Please consider subscribing to my Patreon to have full access to my library of visual effects training, which will help me out to keep making these videos. Thank you.